1. There are functions f of x and g of x. However, f of x and g of x have the same domain, which is -1 and 1. And it says that they have the same outputs for this domain. In other words, the range of f of x and the range of g of x are exactly the same. Based on this condition, we are asked to find a and b. Before solving this problem, let's take a moment to quickly check one thing. When we generally say that functions f of x and g of x are equal, the very first thing we need to check in this context is their domain. Here we have two quadratic functions. The first function has a domain of all real numbers. The second function has a domain restricted to the closed interval from -2 to +2. Both functions are continuous over their domains. In other words, their domains are not broken or discontinuous. In this case, each function is equal only to itself within its own domain. However, if one function is linear and the other is quadratic, they simply cannot be the same function. How can a linear function and a quadratic function possibly be the same, right? That's not really possible in general. What this actually means is that they can only be the same for a specific set of domain values. In other words, for example, we only look at the points -1, 0, and 1. And then here there is 1 and 2, assuming that when it is -1, the y value is 1, and when it is 1, it is also 1, and when it is 0, it is 2. Then what this means is that in a function mapping from x to y, if we call this f or f of x and another one g or g of x, we can look at the domain values -1, 0, and 1. For instance, -1 goes to 1, and 1 also maps to 1, while 0 maps to 2. You can create a mapping diagram like this, showing clearly how each input is connected to an output. This is exactly the same function that matches both. You can also represent this in a table. For example, if you have x and y, you can display it in a table like this. -1 corresponds to 1, 0 corresponds to 2, and 1 corresponds to 1. This is all the same function. The way of writing or expressing the function may look different, but the key idea is that the domain and the range must match exactly. Only then can we say it is the same function. So now let's solve the problem. Since g of x is already given, let's try plugging values into it. If we first plug in -1, g of -1 becomes 2. Similarly, if we plug in 1, g of 1 also becomes 2. What this shows is that both -1 and 1 are mapped to the same output, which is 2. Therefore, since this is how g of x behaves, f of x must follow the same pattern. Let's now plug values into f of x. When we substitute -1 into f of x, which is -a plus b, the result should be 2. Likewise, when we substitute 1, which gives us a plus b, that should also equal 2. If you solve these equations simultaneously, you'll find that b comes out to be 2. Once we know that b is 2, we can substitute it back and see that a becomes 0. Now, since the problem is asking for a times b, the answer is 0,